Hello everyone, welcome back to the channel. Today we are going to solve this problem related to the topic gravitation. Here we are given a small mass m that is under the influence of gravitational field of larger mass capital M. The small mass m is moving in circular orbit of radius r naught with time period t naught around the mass m capital M. If another central force, or let's say another potential energy, is added in the system, then also the particle still will be in the same circular orbit of radius r naught, but now with the new time period t1. We need to find out the value of t1 square minus t naught square by t1 square. There are four options given to choose. We need to find the value of t1 square minus t naught square by t1 square, and its value will be among these four options. So let's begin our solution. So initially the object small m is only under the influence of gravitational field of capital M. Therefore what we can write is potential energy of mass m is completely gravitational potential energy. Let's denote it by Vg, or standard one is using U, right? Potential energy Ug equals to minus gmm by r at any distance r. Okay, and the gravitational force on m due to m is given by, let's say, Fg equals to capital G m by r square, right? How we got this? Since Fg equals to minus dv by, or let's say in this case minus dug by dr, right? So Fg is gmm by r square, as r equals to r naught, force on mass m is given by gmm by r naught square. Also this gravitational force provides necessary centripetal force for m to be in orbit. The centripetal force m omega square r is equals to gmm by r naught square, right? That centripetal force is provided by the gravitational force. So these two forces should be equal. Omega naught is angular frequency and it is related to the time period also. So for the timing, let's write this omega naught square equals to small m cancel out. We are left with gm by r naught cube. Let's not express it into the terms of t. Let it be just like omega naught square. This is equation first. After addition of another central potential Vcr equals to m alpha by r cube in this system, total potential energy of mass m, let's represent this by UGC equals to minus gmm by r plus m alpha by r cube. Therefore, force on mass m, force on mass m in the orbit, let this be FGC, is equals to minus dUGC by dr at r equals to r naught, because the distance still has not changed, right? The object is still in the same orbit, so r changes to r naught. At first, let's find out the derivative of this expression. So gmm by r derivative, negative derivative will be simply gmm by r square, and then minus 3m alpha by r power 4, where r is equals to r naught. So the new force will be gmm by r naught square minus 3m alpha by r naught power 4, right? This force provides necessary centripetal force for m to revolve around m in same circular orbit of radius r naught. Therefore, just like previously, m omega 1 square r naught equals to, we have gmm by r naught square minus 3m alpha by r naught power 4, or small m gets cancelled out in all the terms, so omega 1 square equals to gm by r naught cube minus 3 alpha by r naught power 5. This is second expression. Now let's find so this term here is actually 1 minus t naught square by t1 square, right? So let's find out t naught square by t1 square. Let's find t naught square by t1 square. But we know t equals to 2 pi by omega, that is time period is inversely proportional to angular frequency. This would be t naught square by t1 square equals to, it will be omega 1 square by omega naught square, right? Now we have the relation of omega 1 and omega naught. They are given by equals to gm by r naught cube, gm by r naught cube minus 3 alpha by r naught 5 divided by, and then omega naught square equals to gm by r naught cube. This is gm by r naught cube, and if we separate these terms, it will be 1 minus 3 alpha by r naught power 5 into r naught cube by gm. So this will be 1 minus and t1 square minus t naught square by t1 square equals to 1 minus t naught square by t1 square. This is 1 minus, we have 1 minus 3 alpha by gm r naught square equals to 3 alpha by gm r naught square, that is t1 square minus t naught square by t1 square equals to 3 alpha by gm r naught square. This is the solution. Let's check if any of the options matches. 3 alpha by gm r naught square. So the correct answer is option A. I hope you understood the solution. Thank you for watching this video. If you have any confusion, please comment below.